Hi everyone, I'm Eric and this is our paper Leveraging Sparsity for Efficient Submodular Data Summarization. In this paper we study a version of the facility location problem, where the goal is to select a set of elements that cover some larger set. Given a benefit between elements, we want to select a set of size k that maximizes the average benefit received by every element and its most beneficial element selected. In data summarization, the benefits may be a similarity between elements, and the goal is to find a set such that most elements have a representative very similar to them. We can then define clusters by grouping elements that have the same representative. This problem also has applications to sensor networks, where we want to place sensors such that we can quickly detect events. Let's look at an example. Here we have 5 movies, and our benefit matrix has a similarity for every pair of movies. In this work, we compute similarities between movies with an interesting procedure. We take movie lens ratings of movies and perform matrix completion to complete all the ratings at a large set of users. Then the similarity of two movies is the dot product of their ratings vectors. Say we want to evaluate our submodular facility location function on the set consisting of 2 items, Shawshank Redemption and Tommy Boy. The value of the function measures how well these 2 movies cover the other movies in our dataset. Another way to think about it is how well do these 2 data points approximate the whole dataset in terms of coverage using our similarity matrix. To compute the function on this set, we restrict ourselves only to the Shawshank Redemption and Tommy Boy columns. Then, for each movie, find the largest value from the red columns. Each movie is rewarded the maximum of the 2 similarities from the selected covering set. We then sum these rewards for all columns, giving a total of 3.9. Check that by choosing the set Happy Gilmore and Tommy Boy, we get a worse total value of 3.0. This is intuitive since these 2 comedies are not similar to the other movies and hence provide a bad coverage. Our goal is for a given k, find the k movies that best cover the others. One issue is that many optimization algorithms require calculating all n-squared values in this benefit matrix. Because of this, it was proposed to first sparsify this matrix using nearest neighbor methods. Nearest neighbor methods, such as locality-sensitive hashing, are efficient and available for a large class of benefits. In this paper, we build on the previous work by improving the theoretical analysis of the sparsification error. Specifically, we show that we can zero out every entry in the benefit matrix except for the t largest values, while still guaranteeing that the solution of the sparsified problem is within a 1 minus epsilon factor from the true optimal solution. The required level for the sparsity t for this approximation is order n over epsilon k log n over epsilon k, where n is the total number of elements, and k is the number of selected elements in our data summary. We also showed that this level of sparsity is necessary in the worst case, up to the log factor. We empirically observed that in real data sets, the sparsity can be much smaller while still achieving good results. As an application, we consider finding a small set of movies that summarize a large collection. Here we include a subset of the movies selected, as well as the movies in each cluster with the highest similarity to the representative. Sparsification allowed us to quickly find this set, and we see that our results are quite interpretable, with groupings such as 90s comedies, cult classics, 80s horror, and romance.